Okay, so what we're going to do now is we're going to dive into the actual material, and you, some of you who've had statistics before, can tell me what statistics is. Anyone? Yes. Collecting the data. Oh, okay, I like that. So stats includes collecting data. What is data? What do you mean? I already forgot. What do you mean? Collecting data. Okay. Okay. So then we want to draw a distinction, right? There's a distinction between data and information. Does anyone know what that distinction is? Yes, Armando? That's a good way to think about it, right? So you're thinking about data as something that is maybe numerical or something that is kind of objectively interpreted in that way. Okay. So more or less, right? Data is kind of the raw. Yeah, you want to jump into as well, Deborah?
I was going to say, data is like the raw numbers stuff.
I like that. Yeah, data is the raw numbers, right? And information is something you can actually understand and interpret. Right? Data is that raw, I don't want to say data is the raw information, but data is something like the raw numbers, or just like the list of like, this is the average income in different states and so forth. Information are kind of the words that people can draw, the conclusions essentially people draw from the data. And statistics is that bridge between taking all this raw data that we have, because we're producing tons and tons and tons of it. I shouldn't say tons because it's digital, but whatever, tons of it, and then transforming it into information, things that people can actually use. So statistics is that bridge between those two things. It is the application of mathematics to collecting and analyzing that raw data. Let's take a moment, let's appreciate how big of a deal this is. Because normally when we are working with data, when we're trying to conclude things, and a lot of things that you might think of in terms of experiments, it's a pretty straightforward thing. Like, we're trying to figure out if this drug works or not. And so we're going to have some people here who have the disease in question and they don't get the drug, and some people over here who have the disease in question, they do get the drug. Right? Do this with lab mice a lot, and lab mice are genetically engineered to be identical. And so we have everything exactly the same, except one gets the drug and one doesn't, and we get to see the effect of the drug. Right? That's a pretty straightforward analysis in the grand scheme of statistics. The problem is, for a lot of things that we care about, we can't always do that. Like, we can't, for example, have genetically identical people and do that same thing. We can't have two different companies and then have a kind of manager over here and a kind of manager not over here, because we don't have two identical companies to work with. We can't tease out those issues. So the actual interpretation of all of this data using statistics, it ends up being much more complicated than simply comparing two averages. Okay. You have to really unpack not just the randomness, you have to look at how good the data are, how you collected that data, how you're going to analyze it, and there's a million different ways to do it. This is just our introductory level, so we're going to arm you with the very basic ideas of it, but there's a lot here. Right? There's a lot in this area. So then you think about collecting data, it's not just collecting it, it's also analyzing it, and there's a lot there. Any questions so far? Will we dive in? A little bit more? Great. So let's unpack the sort of types of data when we're looking at what are we looking at? We have something called an element. We have a variable. And we have an observation. Free some space up. Does anyone recognize any of these? You probably recognize variable and observation. You probably have a pretty good intuition of what they are. But in order to really understand what they are, we need to understand the element first. Then we'll take a guess as to what the element is of any data set. Yeah, Julie.
Like the piece, like individual units that comprises the data set that they're collecting information of.
I like that. I like how you're thinking that. It's like what they kind of have all in common. Right? It's what the data are collected on. Here, I think if they have that, it's pretty straightforward. Because I'm going to use this right here to connect it, so I'm going to use that space. What do you think a variable is? Data. So the data is kind of like the actual information. Let me give you an example. Let's imagine our element student. What would be some variables that might apply? Like getting information about students, yes. Yeah. Age. Julie, I think you had one as well. Gender. Ethnicity. School. School. And maybe what school the third, right? We can also have, I'm not surprised you didn't put this in, GPA. So all of these are variables. All of these are interesting things about the element in question. Or notable characteristics, I put note. Notable characteristic about the element. That space. So that what goes here. What goes here? What goes here? Right. The observations. What might be, what is in any individual row? Yeah, what? Data. No. So the people, right, or an individual person. Like this might be Jake. This might be Hiroka. This might be Hakeem. This might be Sue. And then we have this is the data. These are the observations, these are the variables, this is the gender. The thing about for any particular row, any one of these informations, they all have the same element in common. They all come from that element. Like this is Jake's age, this is Jake's gender, this is Jake's ethnicity, school, etc. An observation is one particular part of that element. Particular element of the data set, I should say. Okay. So let's talk about the kinds of variables we can have.
There are two basic kinds of variables.
They are quantitative and categorical. Does anyone take a guess as to what the distinction is between these two?
Yeah, I see.
Counted and categorical.
Yeah. So in other words, quantitative data is always numerical. While categorical data is always the category, right? It's the name of a category. So, which one of these variables is categorical and which one is numerical? It is quantitative. Yeah, Hunter.
The observations of the categorical and the quantitative is like the variables.
I'm sorry, say that again. Oh, so which one of these variables is quantitative and which one is categorical?
Which one of
Which one of these variables?
GPA.
GPA is
Quantitative.
quantitative
And age.
and age, right? And the other ones are
Categorical.
categorical. So gender, ethnicity, school. We good so far? Now the thing about numerical data, about quantitative data, is that there are clear implications. So if Jake is, say, 20 and Hiroka is 19, compare those two ages. Like, one is, so you can say, right, like one is 20, one is 19. You can also say one is younger than the other, right? Or if Jake has a 2.0 GPA and Hiroka has a 4.0 GPA, you can say Hiroka has a higher GPA, right? You can also say Hiroka's GPA is twice as much. That makes logical sense. Now, but when we say Jake is male and Hiroka is female, what does that mean? Can we say any like any relationship between those two, like we can with these? They're human, right? But because obviously these are words. Now, can we assign though? Here's the tricky part. Can we assign a number to male and a number to female? Like male is 1, female is 2. And then start comparing. Can we do this and turn a categorical variable into a quantitative variable? Yeah.
So not for like data analysis, but as expressing it, we need to express male as 1 and female as 2 like next people, but it would just be coding for the category. It doesn't replace the category.
Exactly. So what do you mean, like, not for analysis?
That it doesn't change the nature of the category itself, that you can't make a categorical variable where things are in these discrete boxes into a quantitative variable, but you can sometimes express a quantitative variable as a category.
Yeah.
You could, for instance, express people's ages as you said as their actual age in years.
Yeah.
Quantitative. or you could make some arbitrary cutoff, like people who are older than 25 and
Mhm.
people who are younger than 25.
And put them in the bins. Yes, absolutely. So you can, of course, as you point out, you can turn age into category by just creating random bins and then sticking them in those bins. And you can turn gender into quantitative by just assigning numbers to different names. But as you said, you can't analyze that anyway. The fact that I said male is 1 and female is 2 is totally arbitrary, right? That doesn't mean, like, Hoka has twice the GPA, that makes sense. But Oroka doesn't have twice the gender, right? What does that even mean? So don't fall into that trap, right? They are distinct names for things for good reason. Now, there are ways, right, as you sort of point out, that you can sort of get at that. And we'll talk about when we do dummy variables, how you can turn categories into categorical data into numerical that can be analyzed. Like, for example, with ethnicity, we could say how many, there's all these different ethnicities, Asian, European, Black, so forth. We could turn each one of those options into what's called a dummy variable. And then we can say, is this person white? Is this person black? And it's just a yes or no, 1 or 0 thing. But that requires each option to be its own variable. Right? We can't have a variable like this, ethnicity, and then any number of things, become anything we can reasonably analyze. And that's something, too, that comes up with people's memo proposals, is they will say things like, I think that ethnicity predicts predicts crime rates. It's like, well, we do have ethnicity, we have ethnic variables, in terms of like what percent of a state is black, what percent of a state is white. You can use that, but you can't use all ethnicity at once, because each one of those is its own variable. Any questions on this, by the way? I'm trying to use this space because this is what I'm recording. So I'm very sorry over here. Space is fine. I think maybe I'll switch it over, but I'm not sure I'll be capturing it. I'm still working on this. So, but today's kind of a light day, so it's okay. Oh, excuse me. All right. Let's do this one too. So we also have data called cross-sectional data versus time series. Does anyone know what the distinction is between these two? Yeah.
I guess just taking past maybe one's like one takes a bit more time on the other, like analyzes over.
Yep, exactly. So time is not the element. Time is more or less constant. While time series, time is the element. Is this data here cross-sectional or time series? It's cross-sectional, exactly. Time is not the element, student is the element, and presumably this is all data gathered at about the same time, right? Jake is a student at the same time as Hiroka, at the same time as Hakeem. What would be an example of a time series data? What would be an example of time series data? Yeah, Julie.
Population level over time.
Exactly, population level over time. So I have to see how population grows over time. Now things okay. So here you can see my website. So we talk about. Let's go pull out some data. If you haven't logged on already, please do so. Let's pull out data set 0. And let's take some of these same ideas. Let's apply them to Excel. Yeah. Always, first thing you should probably always do, hit the enable editing button. Because whenever you download a new Excel document, it's like, I don't know, do you want to fiddle around with this? You're like, yeah, I totally do. Shut up. And then you can actually do things to it. I also saved this in a weird way, so you have to scroll left a little bit, and now you can see it. Okay. So I went to my website, see my personal website, under stats2, HTML, and then you pull data set 0 right there. Okay. Any other questions? Great. Now, what is this data of? What are these data? Anyone? Yeah, income, what do you mean, Daniel? Yep, so that's the way, yeah, this is a good question. Is this major, is this recent graduates, or is this all graduates? How do you know? Well, this is, we don't know. Right, we don't know, right? It doesn't say, it says percent of all graduates, but that's just, that's something I'm gonna fill in later, right? That's what we're gonna do. Whenever you are not sure what this data actually represents, you see right down here at the bottom, it has descriptions. This extra tab. So for those of you, I should mention, for those of you who don't know how Excel works, Excel is a spreadsheet program. So we have columns here at the top. We have rows here along the side. And then every single one of these is an intersection. Here I set it up just like we did on the board. Here are our variables. Here are our observations. And what we can do, and any reasonable data set you have will have something like this somewhere. It will tell you what all the variables are, because you can't put all the details here in an individual cell. It takes up too much room. So somewhere it should tell you what all these things actually are and describe it to you in detail. And so here I put it under a different tab called descriptions right here at the bottom, and it tells you what these things are. It tells you where I got them from. So here are my sources. This is where I got this data from. Here is the major, English name of the major. Not all majors are included due to low numbers. And here we can get, where did I get this data from? Oh, and percent of all graduates. Here you go. We're going to fill that in. Majors per 10,000 graduates. The number of graduates per 10,000 graduates that majored in that subject aged 25 to 59. So this is essentially a poll that was done, and it said, hey, did you major in business, or what did you major in, etc. in college? And then the national values are the annual salaries of college-educated workers with the indicated major BA only. Those are only a bachelor's degree. I can't remember. I should probably check this to make sure. Is that BA or BS only, or is that only BA? It's probably BA or BS only. So I might have made a typo there. But notice we see it's nationwide numbers. When you look at the state, then right, we have the state bachelor's. What is that of? What does that mean? What is the state bachelor's? What is that? Exactly, right. And describe here, this is Maryland only, Maryland numbers. What is this 50%? What is that? Half participants? No. No. Average, what do you mean? Closer. Well, what is this data? What is the 69,000, 68, 67,000, 56?
This was the average salary
Yep.
person with the national bachelor's.
Exactly. So these are salary numbers, and you're on it. They're not average. We'll talk about this next week. We got averages, that's the median. Right. So in other words, half of accounting majors make less than $69,000 a year, and half of them make more than $69,000 a year. And so we have these additional cutoff points, like 103,000. What is this 75%? What does 103,000 mean here? Yeah. Exactly. So you are pulling out the descriptions, and you say cutoff point for the top 27 for that major, cutoff for the bottom. In other words, 25% of people make over $103,000 a year if you're an accounting major. 75% make less than that, and 25% make less than $47,000. 75% make more than that. Right, so the cutoff point. So these are the percentiles: the 25th percentile, 50th percentile, 75th percentile. No, what's the relationship then between the state and the national? What do you see? So Maryland's a good state to work in for a lot of them, right? It's higher. Oops. Why do you think it's higher? Does anyone want to take a guess? Yeah, it's more expensive to live in Maryland. So we don't know actually if it's good, right? So Laura, you're saying, oh, it's better. It's like, well, you get paid a little bit more, but if it's a lot more expensive to live here, then maybe it's not a great deal. Huh. What would be nice is if we could figure out how much more expensive it was. Right? Or better yet, at the very least, we can start with what is the premium that you get? Like, obviously, if you're, an accounting major in Maryland, maybe on average you're making, medium you're making $78,000. That's higher than $69,000. But do you come out ahead? So one way we can check, to start, is by looking at how much more as a percent do you get paid if you are in Maryland? Well, how much more does that median income go up? So some of you said you've had experience with Excel. This is a great time to show off. What do you do? Anyone? Like, what do you mean? Like, this will project it out. Sure. But I'm trying to figure out how much, working in state, the median income for accounting majors is X percent higher than the nation. That's what I'm trying to figure out. So does anyone try to figure out? Yeah.
So you're going to want to create an equation where you're subtracting the difference
Yep.
between the state and the national on another level. Let's say the median is 50%. And then you're going to divide that difference by the 50% at the national level.
Yeah, so let's look at the median. You're absolutely right. So let's just focus on that one because that makes things easier. Median, we'll call median premium or something. Nice to give something a title. And so we are going to, so the secret to Excel, as we will find out in this class, is to hit the equals button. Because the equals button is sort of the key. It will give you stats for commands, right, which I'm going to talk about right now. We'll talk about that more next class. But it also is sort of the secret to making these equations. So you start with the equal button. Now, we first want to take the difference between the state median and the national median. So we're going to put that as in our numerator, right? Before we do that difference, we should probably do something else. Anyone know what that is? Think order of operations. We want to what? PEMDAS? No, parentheses, yeah. So we're going to now, I'm not going to write out 78,000. I'm just going to select with my mouse 78,000. And it will recognize I'm selecting I3. So you see it gives me the I3. That's nice. And now we're going to subtract off. So I hit the minus button. 69,000, which is indicated in F4. And you want to hit the actual cells. You don't want to type out the numbers for reasons that will become clear. And then we're going to end the parentheses. We found the difference. And then what do? What did you say we do, Julia? Exactly. So that gives us the difference between the two divided by how much we're starting with. And then I hit enter, and we get this number, and maybe we can press this button right here, the percent button, to turn it into a percent. And let's add a decimal place right here. So this will increase the decimal. There we go. Oh, it's doing that because it's seeing that these are referencing dollars, and it's like these you want dollars. So sometimes it does it, sometimes it doesn't. Just hit the percent button up there, and it'll convert it. Do we have 13 cents? Do we have 13%? Now we want this for all of them. So I guess we could then say, okay, I guess now I'm going to do that again, parentheses, and then that, and then that, and then that, and then that, and then that. Oh, and then turn it into percent. We could do it this way. Is this a good way to do it? No. God, don't do that. Excel is smart. Excel knows that when you're doing something with the references, if you copy and paste it, it will update your references. Does everyone know how to copy and paste? This is like the most important, like one of the most important things you know, because you use it a lot. Don't do it for papers, right? But you use it for lots of other things. How do you copy and paste? Lower right corner? Uh-huh. Ah, you want to skip ahead and do it the fast way. So let's go through the steps for people who don't know how to do this. So the slow way is to maybe right click, press copy, then select where you want to copy it, and then hit paste. Maybe that one, and then it's there. That's what you're saying. We're getting there. I'm showing you all the different. The problem is with that one is, and we're going to do that one at the end. But that one you have to do it a particular way, right? Another way too, by the way, is to know the hotkeys. Does anyone know the hotkeys? Because we use those all the time. Control C for copy, and Control V for paste. Or as both of you have started, the even faster way is to just highlight it, get that little box, and what do? You can drag down, or you can do something even faster, double click. Because if you double click, it will know, oh, I was doing this 13% and you're referencing this stuff that's right next to it. If you double click, I bet you want to keep doing that. And you want to keep doing that until you run out of stuff to reference. And so it stops right here. Even faster. Let's bold that medium premium there. There we go. Ooh, we can even, let's merge and center. Ooh, and let's make that wrap the text. There we go. Just to make it look nicer. And now immediately we see that not every state has a premium, do they? Or not every major, I should say, have a premium. Some it's exactly the same. Some it's actually lower. Who's a sad person? That's chemistry. Oh, look at that. All right. If you're majoring in chemistry, you're actually kind of taking a penalty by being here in Maryland compared to national average. Economics sadly takes a penalty too, but some of the premiums are huge. Journalism, really? Wow. I don't know what the deal with that is. Psychology and social work, liberal arts, etc., etc. Anyone have any questions?
Yeah. How do you make the
So you see this button right up there, that percent button. So when you click it, you can highlight it. By the way, as a side note, if you cut something, so as we can see, if you copy and paste it, it updates the cell references. That I3 became an I5 or an I4. that F3 became an F5, an F4, et cetera, based on where you copy it. Because I went 2 down or 1 down, it updated the cell references 1 or 2 down. But what happens if I cut and paste? Does anyone know? So if you cut and paste, which you can do by right-clicking cut, or if you know your hotkeys, Control X, and then you paste, Control Z, it doesn't change it at all. Because it's assuming that when you're cutting and pasting, you don't want any reorganization. Or you don't want to actually change the values. You're just reorganizing. So in that case, it won't do that. Let's just get rid of that. There we go. So keep that in mind. Don't confuse copy paste with cut paste. Okay. So let's take a look at this data. Can you tell me can you name a variable for me in this data? Well, let me actually start more basic. Can you tell me if this is cross-sectional or time series? Cross-sectional, absolutely. How do you know? Because time is constant, time is not the element, right? Right, exactly. What is the element of this data? What is the element of the data? I think I heard it. Nope. No, I think, I mean, yeah, you could argue, but it's major is what I was thinking of. Major is the element, because all of this data has major in common. For people who said it was group, don't think that just because it's on the far left, it's the element. Right? The group is derived, this is called business because this is accounting. This is 463 because this is accounting. This is 69,000 because this is accounting. Right? If you change it to architecture, these things change. This is business because it's business management, right? It's in the same group as accounting. Right? So it's whatever the other things derive from, that's your element. All the other things are what? What is group? What is majors? What is national income? What are those? Variables. And what's an example of an observation here? Right, business. Yeah. Well, do we even have business? We have general business. General business is in here, I think. There it is. Yeah, general business, general education, general engineering. I just build stuff. I don't know what it is. Which of these variables is quantitative and which is categorical? So quantitative is the salary. The majors per 10,000 are quantitative. The group would be, of course, be categorical. Median premium, too, is something that we created. Is this categorical or is it quantitative? Quantitative, right? Absolutely. And you can sort of see this as who has the best premium. Some have a lot, I have huge premiums. Some have a lot, I have a small one. But it's possible none of them come out ahead, right? None of them are above 30%. If this area is 30% more expensive than the country on average, then actually, in real terms, you get paid less. Right? Even though you get paid more, everything comes in more expensive, and so adjusted for, it's not really inflation, but just for cost of living, you actually get paid less. Of course, you get other benefits, because it's nice to live in the nation's capital for lots of reasons. Free museums is pretty nice. Mostly, it's like work opportunities and matching opportunities with your spouse and so forth. By the way, what is the cost of living difference? And of course, this is just Maryland. This isn't the whole state. This is just the DC area. Cost of living Maryland versus country. Let's see if we can get something. Do they give me a percent? So if 100 is a national average, then Maryland is 113. So that means that it is what percent more expensive? 13%. So actually, accounting majors come out exactly the same. And if we could even do a little thing here. We can say this minus 0.13. Oops, crap, hold on. Sorry, 13. Why did I do that? What the hell is it doing? I want to say this. Hold on, I know what to do. Let's see. Let's turn off the percent. Let's just see what the number is. The number should be, yeah, that's what I thought. So this, oh, it's because it's rounding. That's why it's getting all screwy. Minus 0.13 is that, and then we'll just turn it into a percent. There we go. Copy and paste it down. See, and then you can see who is worse off. Who's better off? Because, so, like, inflation is like sort of the measurement of, you know, how things get more expensive over time. And you can think of this as kind of a locational inflation because it's cost of living. So when you adjust for cost of living, architecture, civil engineering majors get paid 2.7% more in Maryland, adjusted for cost of living, right? After considering cost of living. While chemistry get paid 16% less. Right. This, by the way, I should note, is not the technically correct way to do it by just doing the subtraction. There's a more complicated way to do it that's more accurate, but we're not going to get into that because it's just sort of an exercise. But you can see, you know, it approximates. It's pretty good. Fun fact, too, what you can do. Which one do you think has the best premium? Well, we could go through and we could try to find it. Or if you hit this button right here, that's select all. You go into data and you can hit the sort function. I love the sort function. Make sure to hit the my data has headers option right there. And you'll see what will happen is it will now highlight everything but those top two rows. It will do the top two rows because I merged the major and the group into two because I wanted to subdivide these over here with the natural and the 25%. So it then treats this whole area as the top row, even though it technically spans two. And now it changes these, and so now let's do median premium. And let's do from largest to smallest. And now it reorders everything. And now we can see that journalism, social work, and theology and religious vocation have the highest premium. Of course. So I'm going to select everything. I'm going to go to the sort function, hit my data has headers. Oh, this is sort function under data, under the data tab. Yeah. You select everything with the upper left-hand corner right there, that triangle, this right here. And I'll just select the whole. I could even switch this over to see who is the most popular major. Let's do majors per 10,000 graduates. Now I'm switching to most popular major, and now it's reordered based on that. And what are the first three most popular majors? They're all in the business group. Right? Business management, general business, and accounting. And then we go nursing. But business, you hear about business being the most popular major? Yes, it is by far the most popular major. Any questions? Oh, it's because I merged these cells right here. So you highlight both of them, and under Home, there is a Merge and Center button under the Alignment section. So go to the Home tab, highlight the two things you want to merge, and then you see the alignment right there. You see the alignment section? Yep. Any questions, by the way? Nope. Oh yeah, I'm gonna want those back. I still have like a minute left. Let me just show you how to do this one too, if you're really curious. Actually, maybe we'll do this next time. I'll do a fast version. How many different majors do we have here? Keeping in mind, not all majors are representative. We can find out using the sum function equals summation. Add them all up. I'll do this again next time just so we're clear. 8,320. You can take this, divide by 8,320, and now we see 9.8% of majors are business management. And now you get a nice percent. Technically, it's not that because it's out of 10,000, so technically it's less than that. We can change that to 10,000 if we want. There we go. All right. I gotta let you go though, so we're out of time. We'll go more over Excel next class. I will see you then. Have a great couple of days.